applications to production, we care about it a lot. It is everything for us, right? Getting applications up and running, working quickly, safely, and into production is what everybody at the office talks about. It's the thing that makes us happy in the morning. You know, when we wake up and we're like, we're going to get some applications into production. It underlies everything that we do. And so we hear people talking about microservices. You know, but that's just a small part of this larger discussion about getting software into production. And again, we love production. I can't tell you. If you go to the Pivotal offices, they have brochures. And the brochures say, have a nice dream getaway, a vacation in production, right? We have people that dream of production. They think about it all the time. It's the happiest place on earth. It's better than Disneyland. If you've ever been to production, you know it's amazing, right? We love production. And you should too, right? That's what we care about at Pivotal, is getting to production quickly and safely. Microservices are a part of that discussion. So what we're going to talk about today is the universe of continuous delivery, all these things that sort of come into play. And I think a lot of this will be kind of basic. I think most of you will know this. What you will not perhaps be aware of, I'm sure most of you will, but what you will not be perhaps aware of is what we'll talk about later, Spring Boot and Spring Cloud, okay? So this picture will be a good chance to understand the big picture, and then we'll look at the details, the code. So it all started about 15 years ago with the Agile Manifesto, right? We all understand. How many of you have read the Agile Manifesto? I mean, even if only that, right? It's not new. This is not new. I don't think anybody really needs to be told too much about the Agile Manifesto. Most of us are probably doing agile software development, right? I don't know when the last time I met someone who was very excited about waterfall, you know, like, yeah, waterfall, you know. Do you know anybody that does that? I don't know anybody, right? It's a bad idea, and it's a bad thing, but I think we have a tendency to focus on a very specific subset of Agile, right? There's actually a lot more to Agile than just the development practices like test-driven development and so on. Did you know that there's actually 3 principles in the Agile Manifesto that concern only the process of releasing software into production, right? That's a very important part of doing Agile correctly, and I think a lot of us tend to ignore that part, right? So if you look here, it says our highest priority is to satisfy the customer through early and continuous delivery of valuable software. I think that says that's the first one, right? Delivery is a big, big part of that. Going to production is a big part of it. And we also talk about going quickly, going frequently, right? And so this brings up a question: how do we get there, right? There's a lot of different answers for this, but I think what we have at Pivotal is a great solution, and we should talk about why. So let's talk about the past. Okay, we've always, I think a lot of us have developed software that is agile. We develop it in an agile way. We use test-driven development. Maybe some of us do pair programming. I think a lot of us understand that you should release early and release often, test your code, make sure that small components work well by themselves. And then we write the code, historically, and then we throw it over the wall, right? Throw it over the wall, and then the Q&A team takes the software, and they do tests, and they do manual tests and exploratory testing. And then eventually, if that works out, we go to the DB administrators and say, okay, here's what our software does, but we want to put it into production, so what changes do we need to make to the schema to make that happen? And then we also eventually get it into actual production. There's actually people whose job it is to take that code and to release it. And that's where you get into trouble, right? Is all of this extra work after the software is done, right? And so what happens is you create queues. Software moves from one place to another in queues, and these queues accumulate, right? You get inventory. You know about lean manufacturing here? Toyota, very, very famous. Lean manufacturing talks about this idea of reducing inventory, reducing waste between workstations. And it's a very, very great idea. It's a very, very good idea, and it applies very well to software. You don't want work that moves from one workstation to another to accumulate, to create inventory. You want to be able to move as fast as possible from one exchange to another. Clock time is very different from actual time, right? If I have software and then I throw it over the wall, and then the Q&A people look at it and they spend an hour, they may not be able to look at it until a day later, right? So even though it'll only take 1 hour for them to do it, it'll take an hour and a day for the actual release to happen, at least, right? This creates waste, and we want to remove that waste. This is what we call water scrum fall, right? You hear this a lot. People, they do agile development, but then it's waterfall for the rest of the process. And it creates a lot of slowness. And I think this is not news. I think a lot of us understand this big idea. I think we understand it, and because we've seen in the last 8 or 10 years this idea of DevOps, developers and operations, right? They're together now. They're not two different teams. You have these teams work together. They live in the same team. They become one team. And instead of focusing on handling everybody's operations and handling everybody's applications, one operations team works with the development team, and they are focused on the same thing. So there's no queuing. They are one team essentially. And historically, this has been a bit of a fight, right? Operations is concerned with managing and servicing and maintaining software in production. For them, change is a risk. It presents a threat to the ability and the stability of the system. But software developers, we are being pushed by the business, and the business says, you have to get new features out. We need this for the business. And so there's a fight, there's an inherent tension between operations and development, right? Operations wants to stop change for good reasons. We understand why, and we want to create more change. So they think we're trying to create problems, and of course they think we're trying to create problems. And it's a bad place to be, because both of us eventually, ultimately, serve the business. We need to move faster. We need to be able to deliver new software faster. So it's all about thinking big. It's about systems thinking. That's what Gene Kim in the amazing book, the DevOps Handbook, talks about. There's 3 ways, and I think the first way, emphasizes talking about the whole system, not just software, not just operations. And if you have a shared perspective on both, you can do more together than you can individually. Okay? And of course, the question is, how do you make it so that operations can manage service and evolve software and reduce the risk, right? Well, I think a lot of us know that automation is very important there. Automation is very important, and for a lot of us that means a cloud computing technology. Unfortunately, I have seen far too often, I go to customers all the time, and this is a very common thing, they want to build the platform. And to me that's a little, it's just very crazy. It's like when you meet that person who wants to compile his own Linux kernels, it's cool, but maybe do it on your own time, I mean, it's not something, you're wasting time. You're wasting valuable business time. It's very, very rarely a time to do that. This is a Simon Wardley value chain map. And the map is pretty simple. It has 2 axes. On the bottom, from left to right, it's how fresh or novel or innovative is the idea. If the idea is brand new and it has never been done before, then it is on the very far left. If it is common and everyone has it, like electricity, then it's on the very far right. Commodity is electricity. Electricity is a commodity. Nobody has to invent electricity to do a business today. Okay? And then when we talk about the value, right? We look at this map. This map is actually, you read it from the values that your business cares about. If you are a software company, you care about writing software. Your software needs computers to run, and it needs servers, and that computer needs internet, and it needs power, and it needs chips. Those chips need silicon. The needs are the map, right? What you see here are the different needs. The needs of the business are on the top left. The business cares about software. It does not care about the silicon that's in the processors used to make the chips. If you have a software business and they're making their own chips, that's a waste. You're doing something wrong, right? And this map can show you that. It shows you that, for example, some things are best if you just outsource them, if you just let somebody else manage them for you altogether. Like electricity, right? If you're a software company, you should not be in the business of running your own electric grid. It's a commodity. Let somebody else do it, right? On the other hand, some things you want to buy, you want to pay, it's okay. You can pay good amounts of money for off-the-shelf solutions, for software that other people wrote. Because they're more important and less ubiquitous, less common than electricity, but they're still not what your business is about. And then for the things in yellow, those are the things that your business cares about. And those are the things that your business should invest time in writing good code for. That's the secret sauce that will help you succeed. Those are the things that you should write code for. Everything else, let somebody else do it. The platform on which you run code, the platform on which you deploy code is It's not your secret sauce. If you're spending time with Docker images and trying to get your custom Linux kernels all set up and all that, you're wasting time. You're going to lose the ability to compete in the marketplace. And Amazon.com, they realized this, right? They realized this about a decade ago. This is a very long piece of text. I'm sorry, I don't want you to read it all. It's pretty boring. Amazon's CEO, Jeff Bezos, he talks about what drove them to create Amazon Web Services. And he said that his team was spending way too much time, his engineers and operations people were spending too much time trying to explain to each other what was happening. Because the developers would write software, and then they'd go to the operations people and say, okay, you need to do this, and this, and I need the server, and I need all this, and there would be a lot of synchronization costs. And these synchronization costs slowed down the development and release of new software. And so they created a platform. They created AWS, Amazon Web Services, specifically so that they could have a common set of tools, a common set of primitives that everybody knew how to use. And they didn't need to file tickets to get new hardware, to get new servers, right? I think we understand that story. That's a very basic story. However, that's still very low level, right? That's still very infrastructure-centric. For most of us, there's still waste involved in configuring, managing, and operating software itself on these servers, okay? And so you have to move up the stack a little bit. You have to embrace the platform, embrace anything that makes it easier to manage and deploy software. Because you're not here to run and manage infrastructure. You're not here to manage servers, right? That's not something that's going to help your business. So we have platform as a service. That's the old-fashioned name for things like Roku and Cloud Foundry and Google App Engine and whatever. And these are cloud computing technologies that are optimized for the continuous delivery, maintenance, and evolution of software. Not just message brokers and databases, but software, your software. And of course, how many of you have heard of Cloud Foundry? Curious? So Cloud Foundry is an open source platform as a service. The idea is that you deal with your code and nothing else. Everything beneath your code is easy to program. It's declarative. And it's open source, so other small mom and pop companies, other startups, like IBM. Has anyone heard of IBM? IBM? No? No, okay. Fine. Other startups and small companies like HP. Anybody hear of HP? No? Okay. Well, they have taken our open source, the code that we started, and we've put it in a foundation. And now these other companies, along with a lot of other ones, have created distributions, right? So Cloud Foundry has become the Linux of the cloud. And just like you don't bother to reinvent Linux, you don't need to reinvent Cloud Foundry. Just use Cloud Foundry. We have our own distribution as well, right? Imagine if Linus Torvalds, who created Linux, imagine if he also maintained his own distribution, right? Wouldn't that be the coolest, bestest distribution you've ever seen? Of course it would, right? So that's ours. That's Pivotal Cloud Foundry. But either way, these are all distributions of this basic code. And it's a platform. It's a way to deploy code quickly. We want that, right? Because software is fun. I love running software. It's very, very satisfying to get good code and to see all the tests pass and to be able to deliver new features and see people smile. The thing that takes away my smile is the maintenance of that software, the stuff that happens on day 2, right? Software is day 1. It's very hot. It's like when you drink too much coffee, you know? And then you get very excited, and then the next day it's like, oh, my head, you know, what happened? That day 2 is where you want the platform to handle as much as possible for you. So Cloud Foundry will do that. This is a quote from a gentleman named Duncan McKenzie he's talking about Windows Azure years ago, and I think the metaphor is very appropriate today. It says, imagine if architects, for buildings, had to be the janitors for every building that they designed, so they had to sweep the floors. Once they were done building the software and blueprinting the building or whatever, what if they had to then clean it up? And that's what we find ourselves doing, right? This is not a good place to be. We are not janitors. We shouldn't be sweeping the floors for the buildings that we build. So, okay, we agree that cloud is a good thing. It's a good place to be. And this implies that we want to do it. And how do we write that kind of software, right? Well, this is actually the hard part, I think. This is the part that requires a little bit of extra work, right? And that's why I want you to come to my talks later. I have 2 talks later. You should come to all the talks, but especially mine. If you've got to take a nap, take it now, and then be awake for those 2 later. We need to write software to take advantage of this platform, right? We need to change the way we architect software. Things have changed a lot since 1990, or 2000 rather. So one answer is to take old applications and move them into this cloud environment, right? And we see this a lot. The architecture, the applications that we saw 10, 15 years ago, we used to build monolithic applications. A monolith, of course, is a giant, unbreakable rock, right? It's something it's a whole structure by itself with no breaks. And that used to be a very acceptable way to build software. We would take our features and put them inside of one bit of code, one giant code base, and then deploy the whole thing. So it's a monolithic application. And given the expense of maintaining data centers and the expense of maintaining servers, and given the capacity that our applications had to support at runtime in production, that made sense. And indeed, if you had to build an application today, and your application domain is unclear, if you're not sure about what to do, a monolithic application might be the right way to go. In fact, you could start with a monolithic application and use that as a way to discover the domain, right? The different pieces of functionality that make up your application. A monolith gives you that ability to discover that and to iterate quickly. It's more quick, it's more efficient than, for example, some other architecture, which we'll talk about in a minute. But that's only in the beginning. Eventually, you're going to run into problems. And the problems, we're going to talk about those in a second, have one common answer. And that's what we're going to talk about is microservices. That's what we get back to, is microservices. So, first of all, the obvious thing, and this is what I think everybody spends their time focusing on. It's the least important, right? People say, oh, well, if I move to microservices, I can handle more users. I can handle more traffic at runtime in production. And that's true, most of the time. But who cares? Because a monolithic application for a reasonable audience, for a reasonable user base, will still be just fine, you know, unless you're Google or something like that. You may not have that kind of traffic. Well, maybe not Google, but I mean, you have to be pretty big to really, really need to scale out, right? So that's the least important reason to go to a microservice architecture. It is pretty nice. So this is actually a great diagram from the book called The Art of Scalability. If you have a chance, I would recommend this book anytime. It's huge. It's like that big. I mean, it's you know, crazy. But if you can, read it to your children, read it to your family. It's a good story, all about how to scale systems and organizations, right? And there's this great axis, this great diagram. It talks about 3 different ways to scale software. There's the x-axis going left and right. That's horizontal duplication. That is, if I want to have more capacity, I just scale out the instances. I just put it behind a load balancer and round robin load balance. If I want to scale the data, I use something that is optimized for partition reads and writes, like NoSQL, instead of using a monolithic database like Oracle. That's on the z-axis going up and down, right? And if I want to scale my functionality, I use y-axis scaling. And that is functional decomposition. That's where you break apart your monolithic application into small independent services, microservices, right? So the y-axis one is, I think, the hardest for people to understand. That's the one we're going to focus on. That's what we're here for. Everybody got that photo? Okay, good. So okay, going back. So how many of you have heard of Netflix? Netflix is really, really popular. I don't have to tell you, but it really is. On the internet, the number 1 most watched video is pornography, right? Porn. Number 2 is Netflix. So porn, and then Netflix, and then less than half YouTube. Wow, right? It's crazy. There's so many people watching Netflix in the United States, big Americans like myself, sitting on the couch in the evenings, watching Netflix every night, that something like 80% of all internet traffic is people watching Netflix in the evening hours in the States. The entire internet, 80%. Right? It's a lot. It's a lot of people. And they got to be so successful and they got to be so big by building software that was better quickly. It's not the best ever. It's the best at the time, right? And they got to the market quickly. And so they had to scale. They had to scale their ability to deliver software quickly. They had to scale that ability to evolve quickly. And so Adrian Cockcroft, who was the senior vice president of web operations at Netflix, and then really he's now a venture capitalist at a Battery Ventures in the Valley, but he was responsible for a lot of these really great ideas that they had. And one thing that he realized is that, just like we have been talking about, when you have a monolithic application, you have waste between the teams. And so what he realized is if you want to remove the waste, if you want to remove the inventory between one team and another, one service, one workstation, you need to embrace what are called cross-functional or multi-purpose or feature teams, right? These are teams that are all co-located together and they do one thing and one thing only together. So they work on one thing and they do everything. They do operation, they do Q&A, they do testing, they do development, they do product management. The executive input, business leadership lives on that team for that one particular function, right? And then they still have the platform, they still have to get it into production, but they make that as automatic as possible by using cloud computing. So they get rid of 3 whole different verticals. They get rid of all those 3 last things so that you can move faster. Once you have a feature team, the trick is to keep it so that the code is small enough that you don't have to spend time synchronizing commits from all these different contributors, right? If I have a feature team, but it takes me days and days of waiting for everybody to finish their code so that I can deploy, then I lose the benefits of microservices. So you have to find a small enough code base that you can make changes and then certify that everything is good. You don't have to waste time merging code and stabilizing and synchronizing across all these teams. So that's where you get microservices. And the question is, of course, how do you figure out what is the right size for your code base? How do you figure out what the right granularity for your services is? And this is where you get into the organizational discussion that we've been talking about here, right? This is not a technical discussion, this is an organizational discussion. There's a law called Conway's Law, named for, of course, Mel Conway, who talks about, he says that software will mirror the organization that it serves. The common example is that if I have 4 different teams working on a compiler, then my compiler will probably be a 4-pass compiler, right? It'll take 4 passes to do its work. This law has been proven a lot of different ways. They did a study of open source software, and they compared it to proprietary software. And they said, okay, well, I've got open source, and I've got different teams working on this open source software. These people are in different parts of the world. They're different time zones, different everything, right? Like people here in Tokyo and people in San Francisco, that's, what is that, 15, 18 hours? It's crazy, right? There's no way that we're going to be awake during the same working hours. So what they found is that these open source projects tended to find stronger boundaries or modular boundaries in the components that they work on. So because they need that component to be strong, they need it to be well defined so that other teams can work with it without these human beings being there. Less communication, right? All right. So that modular, that boundary, that has to be, it has to be stronger. And if you are building a business and your teams, your business functionality, the features that make up your application are managed by different teams that don't talk well to each other or they don't communicate well, your software invariably will have trouble communicating with each other as well. That study I was telling you about, where they had the open source software, they found that the proprietary closed source software, often written by companies who had everybody in the same room, had weaker boundaries, right? Because these people are in the same office. They're in the same office, in the same place, during the same time, so they can just turn their chair around and go, hey, I've got an idea, you know? They don't have to create a strong boundary, a modular boundary. And these boundaries, that helps us tease out what we should do for our microservices, right? Business functionality, business-specific, singly focused business functionality. That's a natural candidate for a microservice. When you move to a microservices model, you get a chance to also focus your domain, right? This is very common knowledge, right? There's this idea of domain-driven design. There's an amazing book by Dr. Eric Evans, and he wrote a book called Domain-Driven Design. It's this idea that if you have a domain and you have different verticals of the company, parts of the domain may mean very different things to different groups in the company. So in this example, there's a concept of a customer. And the customer, when you're in the sales team, means a very different thing, right? That's somebody you're trying to sell software to, that's somebody you're trying to really impress, and that's somebody who hasn't paid any money yet, right? So the process for dealing with that customer and the way you should think about that customer is very different than the way that the customer service team thinks about a customer. It's a totally different thing. The weight, the value, the importance is a totally different thing. The domain in that case is not consistent between the two. And if you have microservices, you're given a chance to use small, bounded contexts, bounded domains, focused domains, right? It gives you the chance to break apart these things that are confusing, that are inconsistent. So, if you've been following thus far, you know microservices offers a lot of value. It offers a lot of benefits. All of this, however, of all these things, to me, again, the biggest value of microservices is that it enables iteration. It enables us to go faster and to do more. All of the modern things in computer science, all of the modern things that we talk about in computer science and all these conferences and so on, they're all designed to prioritize quantity, right? Quantity and velocity over quality. I would much rather use cheap, lightweight unit tests and do lots of them and run tests every build, every time I do a compile. I'd rather do that than have human beings do a really good job once a month, right? I want cheap tests. Those tests will only catch 80% of the bugs, but they let me move faster because I'm able to get the feedback from that test. When we do agile development in Scrum, what we are saying is I want the ability to release software and get it into the hands of users quickly and frequently. That's much more important than saying, oh, we're going to release one piece of software in 2 years and people are going to love it. You don't know that, right? In 2 years, the market may be gone. Look at Windows, right? Windows, they build software and they say, oh, in 2050, we'll have one new piece of software and it's going to be amazing. And then, of course, by then, no one is even using it. Nobody even cares, right? You miss the market if you wait too long. So you want to get it in the hands of users and you want to get that feedback. It's all about improving your ability to get feedback. Put it another way, if you wait for all of the data to make a good decision, it may be too late to make any decision at all, right? Everything in computer science is about giving you the ability to make that decision more accurately with rapid feedback. Adrian Cockcroft, back at Netflix, he talks about this as well. He said that people in the organization used to say, well, this isn't very efficient. This thing that we're doing isn't very efficient. And he said, it may be true that it's not efficient, but if it works, then prioritize new features, prioritize new releases. It's another way of saying premature optimization is the root of all evil. The business will not get better if you make something just a little bit faster. It will get better if you deliver new features. If you deliver new features and the business makes money, that is efficiency. That's what the business cares about. That's the ultimate efficiency. The actual request response time for a specific service, that can lag. Okay. To really put to really emphasize this point, Adrian talks about this observe, orient, decide, and act loop. Right? And this is a military term. It comes from the military and it comes from strategy and theater, right? But it actually really applies to business as well. It's very common to have this loop, and we use it all the time. We just don't know it. So do you know, if you ask people at Netflix, they don't think of themselves as a streaming video company, because let's be honest, streaming video is easy. We can all do that. I mean, I know most of us are probably capable of writing a little bit of software to stream video, right? That's not actually all that hard. In fact, you can buy or use open source software to stream video. They don't think of themselves as a streaming video company at all. They think of themselves as an analytics company. The data tells them what to do next, right? So, for example, they are able to look at TV shows that are being run on Netflix that are streaming. Last 5 minutes. Can I have 6? 7. Okay. They're able to look at the videos that are running on their system, and they're able to say, oh, well, if somebody dies in this place in the last 10 minutes of a TV series, in the next episode there's going to be more people. They will come back for sure. But if it's boring on the 6th episode, then they won't come back for the rest of the season, or things like this. They're able to see what happens based on the data that they get from the system. It's not surprising then that they succeed, right? It would be surprising if they didn't succeed. It'd be terrifying if they didn't succeed. The data is telling them exactly what they need to do. And that's why Netflix now has TV shows that they build, that they're directing, they're producing. And these TV shows are amazing because the data tells them exactly what they needed to write in the script to make it work, right? That data is stuff that they care about. That's what they care about. They do this also for the website, right? You can't know what the user is going to do until you actually give the software to the user. So Netflix is optimized for doing some tests in production, right? They care about getting the software into production. They have these things called blue-green deployments, or I'm sorry, canary builds, canary features, canary tests. They'll take a new build of the software and they'll make it available for just 10% of the audience, not all of it, just 10%. And 10% will get the new feature, and if the feature is working and people are able to use it all the way through and they get the right results, they'll say, good, it's good, we're going to go ahead and deploy it to everyone. But if it's not working, then they can roll it back and nobody even knows it was there. They're using the whole customer base, they're using a significant percentage of the customer base to get data about how to react or how to change, you know? And so in this way, they can move very quickly. They let the data drive their next decision. And so that's what you see here. You create innovation from a potential gap in the market. You release it. You do analysis on the data, and of course, for that, something like big data is very helpful. If it's good, great. Otherwise, you make a change. You decide what to do from there, and then you act. That loop continues all the time. It's all about making that loop go faster and faster. And when you embrace the OODA loop, OODA, one common way to get that is to use continuous delivery. There's a great book by a gentleman named Jez Humble and David Farley, and it's called Continuous Delivery, Reliable Software Releases Through Build, Test, and Deployment Automation, right? This is from 2009. Amazing book if you get a chance. And in that book, they discuss this idea of a build pipeline, where they automate as much of the software development and release cycle as possible. So that after every git commit or subversion commit, I have a suite of automated tests from my unit tests to my acceptance and feature tests, all the way down to my manual, potentially manual, exploratory tests. In theory, every commit could go to production. And that creates a freedom, right? Because the scariest thing about production is the fact that we don't do it very often. But if you do it every day, if you do it 10 times a day, the fear goes away. Well, again, you need automation for that. You need a platform, right? And you need software that is small and singly focused. That's what we talk about when we say microservices. So there's a gentleman named John Alspaugh who was at Flickr, and he's the one that helped Flickr, the photo sharing service, grow to a large scale. And he's also at Etsy. And he changed the world. I remember when he started, he gave a talk at a Velocity conference in 2008, 2009, something like that. And he talked about how Flickr was deploying 20 times a day into production. It's not unusual now. I mean, there are companies in the Valley that build when they have a new employee, the new employee gets a laptop and they say, okay, build a feature and you're going to go to production with it today. Your first day, right? You take away the fear of going to production. You make it something that it's safe to do, and the risk goes away. That goes back to what we talked about earlier. Operations want stability. So if you build in the safety into that process so that the stability isn't gone, then it's easy to do, right? And that's through automation. So, of course, you need to build software differently. Like I said, the architecture today for building applications in this style is very different from what we did 10, 15 years ago. You need to build APIs, right? Microservices are all about APIs. Amazon started building REST APIs for everything. They said that two teams cannot share databases. They have to talk to each other through APIs. So what you need is a framework, some sort of technology that helps you build APIs quickly and make them production ready quickly, right? That's Spring Boot, and we'll talk about that a little bit later today. However, when you start creating lots of small services, you run into some other pain that is introduced because you have services that are talking to each other. And these pains are fairly predictable. Other companies have already solved these pains. Things like service registration and discovery, right? Things like aggregate or dashboard views of the data of the system. Things like single sign-on, right? Or distributed tracing. If I call one service and then another service and then another one and something happens in the middle, what do, right? These kinds of problems are only there if you have lots of small services. If you have a monolithic application, of course you don't have these problems. The good news is you don't have to solve these things by yourself, right? We know that distributed systems are hard. We know that there's pain. But other people have solved these problems before. You don't have to reinvent the wheel, right? And so what we have done with Spring Cloud is we have built a set of tools and components on top of really, really great stuff from Netflix, from Twitter, from Amazon, from Apache and Contool, and all these great open source projects. We've provided an integrated, cohesive framework for building microservices, for building distributed systems. And when you take all these things together, you have an opportunity that we didn't have before, right? The cloud gives us the opportunity to deliver more features and to do so more efficiently. People always say, well, if the abstraction for programming today is going to keep up with the graph of productivity that we see in hardware, then by extension, software should be 15,000 times more productive than it was in the 70s. I don't think that's going to happen for a long time. The way we get to achieve efficiency and productivity is by optimizing all of the stuff around the software, right? And that's continuous delivery. So I thank you for your time. We will talk about this stuff later. I hope you'll join us for that. Thank you very much for your time, and I'll be happy to take questions, and I'm sure I can get on stage and everything. Cheers.
時間も必要ですけど、何か質問がある方は、より2人ぐらいですかね、挙手いただければと思いますけど、いかがでしょうか。
I have questions, and I was paying attention. No questions?
Still shy?
Oh, don't be shy. Okay, well, we'll do it outside. If you have anything, I'm here for you. Okay? Cheers.
じゃあ、キーノートの方を終わらせていただきます。ありがとうございました。本当は前の方に来ていただければ、まだぜひ残ってます。あと、この後も2つほどセッションありますので、その時も聞いていただければと思います。あと、レシーバーですね、後ろの方にスタッフがいますので、退席される方、回収していただければと思います。で全体的にですね、ちょっと最初、我々の方で回ってしまって、もう読めなかったんですけど、10分ほどスケジュールをずらさせていただきます。時計は、ここの時計ですと大体5分ぐらいなんですけど、全体は10分ほど送らせていただいております。よろしくお願いします。
Hi. Sorry for seeing this. As long as they're happy that I'm happy. Sorry. Sorry to